So we need to find the electric current passing through 2 ohm. So this is a circuit, closed circuit, as you see. So at the beginning we don't know the direction of the electric circuits, and actually we don't need to guess because this is a bit complex circuit. So let me say here we have a 12 volts, here we have a 8. So likely I1 will be passing in this direction. I assume, I'm not sure about its direction. And it's not important actually. It means if here we have I1, it means here also we have I1 to the right in this direction. Electric current passing through from this part, let's call it I2. And this is direction. Again, I'm assuming, I'm not sure, and it's not important. According to the Kirchhoff's first law, electric current passing in this direction, or again, I'm not sure about this direction, maybe in this direction, let's call it will be I1 minus I2. So at this point, two electric currents coming like this. If we add both of them, it should be equal to I1. It means electric current passing here, it should be I1 minus I2. Of course, we can use another variable I3, but it will be, in terms of mass, we will have more equations. I'm avoiding more equations, that's why I'm not introducing new I3. I just call it quickly I1 minus I2. Now we need to apply Kirchhoff's second law. We have two loops basically here. This is a first loop. Let me call it loop A. According to the Kirchhoff's law, second law, all voltages, potential differences here on this line, if we add them, it should be equal to 0. This is Kirchhoff's second law. So basically we can write like this: sum of all voltages in this circuit should be equal to 0. Now we should apply Kirchhoff's second law very carefully because of signs, positive, negative, etc. So here we have 3 elements. We have a battery, 4 ohm and 2 ohm. Basically 12, this one, plus or minus 4, for I1, electric current passing through this one is I1, and the voltage of this 2 ohm, which is 2 times I1 minus I2 according to the Ohm's law, should be equal to 0. Here now we should be careful with these signs, which one is positive, which one is negative. So let's start with battery. As you see, our loop is direction of the loop clockwise in this direction, from positive to negative, so it will be negative 12 ohms. Here electric current is passing to the left, loop is going directed to the right, so they are opposite, it will be positive. Positive, same for 2 ohms. Electric current is passing to the right, but loop is directed to the left at this point, clockwise, so opposite. Electric current and the loop's direction opposite, so we use positive sign here. So basically 12 equal to 4I1 plus 2I1 minus 2I2. Basically 12 equal to 6I1 minus 2I2. We can divide by 2 both sides, so we'll have 6 here, 3 here, and just 1 here. This is equation number 1. Now let's apply Newton Kirchhoff's second law for this loop. Let me call it loop B. According to the Kirchhoff's second law, all voltages among this line, among this circuit, if we add it, should be equal to 0. Here we have 3 elements. Battery 8, 6 ohms voltage, 6 times I2, and 2 times I1 minus I2 should be equal to 0. So here, let's start with battery, plus, minus. So loop is passing through, it's directed to the left from plus to minus, so it will be positive 8. Minus, negative. So from plus to minus, loop is directed like this. So it's a negative 8. Now let's come to the 2 ohm. Electric current is passing to the right. Loop is also directed to the right. So same direction, it will be negative. Let's come to the 6 ohm. Electric current is passing to the right. Loop is to the left at this point. So opposite, so it will be plus. Now it further is just mass. 8 6i2 minus 2i1 plus 2i2. 8 equal to 8i2 minus 2i1. We can divide both sides by 2. 4 equal to 4i2 minus i1. This is equation number 2. So we have 2 equations and 2 unknowns. So we can solve this problem. So from here, i2 equal to 3i1 minus 6. Let's bring it into the equation number 2. So 4 minus equal to 4 times i2, which is 3i1 minus 6 minus i1. In this equation we have only one unknown, i1, and we can solve it. 12i1 minus 24 minus i1. 4 plus 24 equal to 11 i1. Here we have 28 11 i1. So i1 equal to 28 over 11. As you see, we have a positive value, positive i1. So it means our direction for i1 is correct, and value equal to 28 over 11. Now let's come to i2. 3 times i1 equal to 28 over 11 minus 6, and at the end this will be equal to 18 over 11. So this is a i2, but question was find electric current passing through resistor 2. We know that from resistor 2 electric current equal to I1 minus I2. So we need to calculate I1 minus I2. This is a electric current that will be passing through 2 ohm. So 28 over 11 minus 18 over 11, it will be equal to 10 over 11. 10 over 11 ampere will be passing through ohm 2, resistor 2.